Hello and welcome to this section of the differential equations tutor. In this section we're going to continue solving these homogeneous equations with constant coefficients that have real roots of the characteristic polynomial to construct these solutions. Now I'm going to say right now you already know the solution method. There's nothing really new here. But it's kind of like fractions when you're in third grade. I mean, you know how to add fractions. Even as an adult, you know how to add fractions. But still, if I ask you to add 57 192nds plus 37 fourths, then it's going to take you some time to do that math, right? Same thing here. We know how to do it, but we still need to roll up our sleeves and get some practice with doing the more complicated things. So let's just jump right back into it and go with our next problem. Sometimes your problem is given to you in terms of a differential equation, and then you have to write it in terms of operator notation like we've been doing before. Sometimes, depending on the book you have, the teacher you have, they might actually give you the differential equation already written in operator notation. So in that case, this would be an example like that. So if you had d squared, d plus 1 cubed, d minus 2, 3d plus 5, 2d minus 3. Operating on x is equal to 0. So don't get too scared off by this. Just realize that everywhere you see a d is a derivative, right? And the powers really are just like this guy's a second derivative and so on. So don't get too worried about that. But if I gave you the differential equation in all its glory, and you were able to rearrange terms, and you'd be able to write it in this operator notation that I'm given to you here. Sometimes it's already given to you in that notation. Okay, so what do? We've already got it in that notation, so we just write the polynomial down. So we have r squared, we have r plus 1 cubed, we have r minus 2, we have 3r plus 5, 2r minus 3. Operating on x, whoop, it's not operating on x, this is the polynomial, equals 0. Okay, so now we have that characteristic polynomial looking like that. And at this point, you just basically do what you already know how to do. This guy, this is r is equal to 0 with a multiplicity of 2, right? This guy, this is r is equal to negative 1 with a multiplicity of 3. Because if you think about it, if you set this term equal to 0, and then you take the 1/3 root of both sides, well, another way to think of it is this guy is actually r plus 1 times r plus 1 times r plus 1. This is what this really is. Just like up here, this is d plus 1 times d plus 1 times d plus 1. So it's derivatives multiplied by each other, basically, is what's happening there. So when you take this guy like this, then you just solve for the root one time, and notice that since you kind of have 3 of them there, it's a multiplicity of 3, so that's how we get that. This guy is r is equal to 2. This guy is r is equal to negative 5/3, and this guy is r is equal to 3/2. You should be able to convince yourself that this is all you're doing here. You're just taking each of these terms and setting it equal to 0. Just like you might expect. And at this point, you just go ahead and write the solution down. X of t is equal to c1 times e to the 0 t from here, plus c2 times t e to the 0 t from here. Multiplicity 2, so I added a t here, plus c3 e to the negative t from here, plus